Hello and welcome to another open source silicon stream. I think we're at number 5 now. Notoriously bad at counting. Start at 0 or start at 1. And I've got a couple of people in the chat to say hi to. Hi, Stixu. For people who don't know Stixu, they have a cool app to do stick diagrams. And if you don't know about stick diagrams, that's worth having a look at. It's kind of standard cell design stuff. Stixu, if you want to drop a link to your app in the chat, that'd be cool. Sylvan says hi. Hi, Sylvan. Glad you're here. Sam saying, are we doing custom level shifters today? I don't think so. I will talk a little bit about where we got up to last week and what we are going to do. I think what I'm going to do is more likely to be focusing on an SPI peripheral design I want to test, because I want to put it SPI inside my VGA clock. So having said that, let me present my screen. And talk about the news. So welcome. Usual time, Monday at 5. Put it in your calendar. This is a regular event, although I'm not totally sure if next week I'm going to make it. So I'll talk a little bit more about that at the end. Feel free to ask comments or questions as we go along. That's one of the reasons I'm doing this, is to have like more interaction, more engagement with people, to find out what they're interested in. And if any of this stuff is interesting and you want to get more involved, then join the mailing list. Join one of my courses. I've got a digital and an analog course. Make a tape out on Tiny Tape Out 10. We just moved the closing date to Monday the 10th. That's a bit of news for you. And join the Tiny Tape Out Discord. There's a really good active community there. Hi, Aravind. Welcome to the stream. So on the news front, I just want to plug the eFabless webinar, transitioning from FPGA to ASIC. That's opened up in a different screen. Let me see if I can deal with that. Window. How about that? Here we go. Transitioning from FPGA to ASIC. That's on Thursday, 6 p.m. set. So it's like 1 hour later than the start of this stream, and it's on a Thursday. If that's interesting, then you'd need to register here, and then that's like done by eFabless on Zoom. They're really good webinars. As probably, I think, actually, Anton, who's a friend of Tiny Tape Out and from an alumni of the Zero to ASIC course, often runs them, does a really great job of them. So yeah, recommended to check that out. Demo scene entries. So Tiny Tape Out 10 demo scene competition is open. And one thing I just published is the demo scene entries we got from Tiny Tape Out 8. So you can check out all the amazing entries that people put in here. There's so many that I love here. Here's a simple one that is classic. And this video's got them all, so you can scan through this video to check out all of the different entries. And even better than that, you can click on the design and then have a look at kind of how much logic was needed to realize it, and then you can look at the repo to find out more information. So Tiny Tape Out 10 demo scene competition is open right now. And it's free to enter. You even get a free tile if you do an entry. So if you want all the information on that, then check out the demo scene competition rules page here. And we've got some good prizes as well. This is going to be one of the prizes, a classy wafer in a nice stand there. You want to win that. Hi, Sive or Seve, maybe. Excited to get started. Great. Welcome to the club. Good to be excited. Dat Nguyen is saying, can you share your experience about designing ADPLL? I'm afraid I can't. I don't have any experience with PLLs, but people can do that kind of stuff. So a good place to ask would be on the Tiny Tape Out Discord, maybe in the analog channel. And Sam says, ooh, shiny. Yes. Okay, so I already mentioned Tiny Tape Out 10 was moved to Monday. If you ever want to know when the next runs are, they're on the Tiny Tape Out chips page. So after 10, if you miss 10, oops, then 11 is going to be in June. And we just pushed back from a request from the community to, instead of closing on the Friday, closing on the Monday, so people have one more weekend to work. All right, so little look at Tiny Tape Out in the news, in social media news. Matthias is using Tiny Tape Out for the Julius Maximilians University in Germany, and they did a bunch of tape outs, including a 32-bit RISC that we actually saw on the Tiny Tape Out 6 Bring Up channel. That was cool. Dinka Goken is using at Hacettepe University, and they're going to be continuing to use Tiny Tape Out for their future designs. So if you want to publish stuff and get it pulled up on the stream, then just make sure you tag Tiny Tape Out, or use the Tiny Tape Out hashtag. Fran Scarman is a serial offender on Tiny Tape Out, and he's back to do more crazy designs. This time he's got I think a 256-bit shift register connected to a NAND gate. So by programming that shift register, you can kind of make it do whatever you want. You can check out this is designed in a boring demo, he says, back with another visually uninteresting demo. So thanks, Franz. Good to see your design working. And then a great one from Kolosh, who took the 0 to ASIC analog course and did a mixer, Gilbert mixer. And he's recently tested that and got it working. So that was great news. Yep. So some news on local latest silicon. Uri's just done this. So if you don't know, we have in silicon proven designs, we have like a list of all the designs that have been tested in silicon, which is fantastic. But we just connected that up to a Discord robot. So when a design is tested, it's going to ping you. When your design is tested, it's going to ping you. So we just saw here, like Michael Bell tested his Tiny QV. And I think we saw something in Tiny Tape Out 7 as well. Yep. R. Nunes. So who's R. Nunes? Ricardo Nunes. Recently tested the 12-bit differential SAR ADC. So great to see that working. And one more we had here was Calonso 88. So this is actually the design I'm going to have a look at later on in the stream. An ALU with an SPI peripheral. So congratulations, everyone, for getting your designs tested in silicon. That is fantastic. Well done. And then Sylvain did a really great experiment that I want to share here. Hi, Sylvain. That's what Sylvain looks like, if you don't know. And he used a pair of Tiny Tape Out boards. I think one is 6 and one is 7. he's got some fairly custom boards because he does our characterization. The chips go to him and he does the measurements before they get sent to our CM and assembled. So he's using Kolosh's RF mixer with the local oscillator provided from the RP2040, mixing down an FM modulated radio signal at around 30 megahertz, I think, down to 500 kilohertz, and then using Karsten Wolf's SAR ADC to sample that at 500 kilosamples a second. I might be wrong there. Then using the Glasgow Interface Explorer board to read that into GNU radio, and then it's got a FM demodulator pipeline. So I won't spoil the surprise, but it's a really good video, recommended viewing if you want to know more about radio and SDRs. Sylvain's got a lot of experience in that, and it's really, really cool seeing radio happening and earlier than I thought. So I said that 2025 I wanted to see more radio happening on Tiny Tape Out, and so this is a SDR implemented with 2 Tiny Tape Out chips. So good job, Sylvain. Really like to see that. Lovely video as well. Highly recommended. So that's the end of the news. Let's just check the comments. Jabe says, do you have a Discord or Discord community? Yes. So that is, actually, I think I might have a banner for that. There we go. Just a short link from our website. You just go to tinytapeout.com/Discord to join. And yeah, there's a Slack channel, the Open Source Silicon Slack. And Sylvain is correcting me and saying it's sampled at 4 megasamples per second, actually. Nevertheless, great work. So I wanted to look at a couple of things. So last time we looked at, let me just turn off this banner. What's probably the easiest way for me to get this is to go to here. So we were working on this design, and I think I was just struggling with getting LVS to work at the end, which I did get working. And it's basically a very simple, small digital block, but it's powered from the 3.3 volt line. And the idea is that we can turn down the power supply to see what happens as it runs at a lower and lower voltage, and then using the analog pins. Now, it turns out that that's not actually a great idea, because the mux that we use for the analog pins is powered by the 3.3 volt supply. So as we turn down that voltage, we're also going to be affecting those signals. So a couple of people said to do level shifters instead, and that's what Sam was saying earlier. Are we going to do custom level shifters today? Didn't feel like I was going to be able to do that today. I need to do a little bit more research. Thanks for sharing the paper that you shared on that, though. So I'll do a bit more looking into that, and then that's like a topic for a future stream. The problem that I had with the LVS is absolutely classic LVS problem. Fix LVS. So it was a typo. It was like I had reset N and it was N reset. And I think because NetGen, the LVS tool that we use, has a kind of built-in Verilog parser that's not very powerful. It doesn't really complain about things like missing symbols or net names being wrong. It just silently does nothing with them. So probably in the future, what I should do is either lint this as part of my LVS, because that would catch things like this. And yeah, this was just a silly typo. Okay, Aravind is saying, share the FPGA to ASIC link for me, Fabulous. Will do. There you go. Timon, hey, welcome to the stream. Nice to see you here. Hopefully you're going to see you in Hackaday Berlin. Are you going to go? That's actually another thing to plug is Hackaday. I'm actually wearing a SuperCon t-shirt today. SuperCon. This one is even better because it's closer in Berlin. So if you're in Europe and you're around, then check out Hackaday Berlin. It's a really good event. So anyway, that's what we did last time. Oh yeah, cool. Good. Looking forward to seeing you and the rest of the gang. So the next thing, so going to look at a bit more on that design for the low voltage operation of digital designs on a future stream. And what I want to look at now is this design. So from Chao Alonso da Costa, SPI peripheral and 8-bit ALU. So he wanted to implement an 8-bit ALU. And yeah, logic unit 7481. Let's take a look at that. Oh, he's even got a nice documentation. Ah, I recognize it. 4-bit slice arithmetic. Anyway, it's got too many IOs to work with tiny tape out. And so what Chao decided to do was, and it's doing 2 times the replica as well, use a multiplex to tap different parts of the logic design, and then use an SPI slave peripheral to load and read data into and out of the design. And I've got my VGA clock that I submitted on my very first ASIC and pretty much every ASIC since then. And I would like to show it a little bit of love and maybe kind of upgrade the font and have some of the stuff, like being able to control stuff in the background. And I also want to be able to set the time. So at the moment I have like this really crappy time set script. Let me see if I can share this. So if I do update TT time, it resets the ASIC, selects the VGA clock ASIC, enables it, provides it the correct clocking, reads the current system time, and then basically presses that the second adjust button 59 times, the minute adjust button 19 times, and the hour adjust button 17 times. And now I've got the time set on my ASIC clock. But it's not ideal. For example, it's got the time set now as 5:20, 17:20, because by the time it had got all the way through, the second counter had rolled over and added 1 to the minute. So what I'd like is to be able to set the time through an SPI register, have one for like minutes, hours, and seconds, and then like be able to change the colors and fonts and stuff like that. So I've been looking at some of the designs, and came across this one that has got this ALU, but it's also got this SPI register. I think I'm going to just share my entire screen now. And yeah, take a look at this design. So I've already got Aravind is saying, can we look at an analog design? Maybe, probably not this stream, but on another stream. Rohan is saying, why not simulate RTC clock instead? Yeah, I could. I mean, that would be a way of like, and then having battery powered backup. I guess you were saying on there. Could do. Still need to set the time that first time. And the other thing is, like I said, I want to be able to control fonts and backgrounds and stuff like that. So I want to add an SPI register to get more control over the design. And this one is a nicely documented one, and it's already been silicon proven once. So what I want to do is have a look at it. So I'm going to start up the commander. Not that one, because that's my clock. Okay, TTO7, and yeah, that's the one I want. All right. And then this is the pinout. So we can control the type of SPI peripheral it is, like with the CPOL. That's clock phase, is it? No, that's clock phase. That's clock polarity. And then here on the bidirectional pins, we've got the meso, chip select, inverted, the clock, and the MOSI. So I think what I'm going to do is connect up the scope so we can see these happening, and then we'll try and send some numbers and see what happens, see if we can get the ALU working, have a look at it, and take a look at the Verilog. So I'm going to put this camera on. And I can't remove myself because then I'll lose audio. I've learnt my lesson. But I can solo this layout and you should still be able to hear me. I'll check my screen in a second if you can't hear me. Okay, so it's bidirectional 3, 4, 5, and 6. Okay, and then put the scope on. Thanks to Keysight for the very nice scope. And nothing's happening at the moment, which is what we're expecting. All right. So very nicely, Chow has given some. Hold on. This is out of date, so hasn't been merged into the repo yet, and the most up-to-date stuff is here in his GitHub. So this is the address space. These are the registers. And we've got some code here to initialize the SPI, which is really, really handy. Look, I can just copy that in the REPL. Control E. I don't actually know what this means, this paste mode. Does anyone in the chat know what paste mode is? And do I need to now press Control D to finish? Oh, look, something just happened on the scope. So what this is doing is basically giving us an alias. So 3, 4, 5, and 6 are our meso, clock select, clock, and mozzie. And then being able to initialize this with pull downs, and then soft SPI with the baud rate, and then all of this information here. Sylvan's saying it avoids automatic smart indenting. Right, great, thank you. Yep. All right, so that is all now set up and ready to go. So I should be able to write to an address like this. Oh, I think, yeah, it just did something then, didn't it? So let's change this back to triggered. All right. Slightly shonky looking waveform there. Now got to work out which signal is which. And I don't yet have this one turned on. Ah, look at that. So that's 4 is obviously clock. Yellow is chip select. And then what was this? This was a write. So that will be mozzie. And then if we do a read, then we get the green one. So that's meso. So let's try and get this decoder set up then. So clock is channel 4. Chip select is, yeah, green. I think that's right. What did I say? Mozzie is the blue one. All right. And then, is that right? Which one was which? Yellow is chip select. All right. Thanks, Sam, helping me out in the chat. I appreciate it. All right, let's run another write. All right. Okay, that's looking pretty good. Let me just move this around. Okay, so we're seeing an 80 and then an A5. That's been correctly decoded. Let's change that. Looking good. So what that's doing is, if it's an 8, it'd be good if these were, because this is all done with Wavedrom. Be good if we could embed that in the data sheet. That's right. Did I get that? Yeah, that's what it is. Right answer. Okay, yeah. Address 3210. This is don't care. And that first bit is high. So let's just run that again. So there's that first bit there. Let me just zoom in a little bit. Can I drag that? No. Whoops. Maybe I can trigger on falling edge instead. Makes more sense, doesn't it? Okay, but there we see that. So that one bit is high on that first clock. And then the next byte is, and then that's the address. So we're writing to address 0. Which is here. That's data A. So this is like how the ALU works. We put in something in data A, we put something in data B. So I should be, after writing it, I should be able to read it. And if I want to read from the same address, I need to do that. Okay. It's interesting it's not decoding that this time. But I'm getting the right value here. So if I change it to write something else and then read it. Oh, it's changing it into ASCII for me as well. Is it like that? There we go. Yeah, so that's working pretty well. I wonder if it's because I'm just, is it because I'm too far out? Will it decode it now if it's all on the same screen? No. But a write works. Oh no, write doesn't work anymore. Pretty weird. What changed? Oh, now it's back. Maybe it was just a that threshold thing. Yep. So that's great. I'm going to validate. I'm going to give feedback, report results. Didn't check the ALU, but the SPI registers seem to work fine. And then maybe let's take a look at how this is actually implemented. There's also a test that is good to see. So I have actually cloned this already. Here we go in the test. Let's take a look at how the test works. All right, so this is writing on all the registers and then reading them all, writing some random numbers and reading them. So that's essentially what I've been doing. And then that's cool. It's also testing with the opposite clock phase and chip select polarity. Nice. Then I'm not sure if that's testing anything to do with the ALU though, or if it's just testing that the registers work. I didn't see anything about the ALU. And then let's have a look at info YAML. So 1x1 tile. These are all the source files. So I need to work out what I need to take for my project. So probably not going to need these. Falling edge detector. I might start a new tiny tape out project. So I need falling edge and rising edge. What's reclocking? That's going to be used by the synchronizer. Let's take a look at this top level. How's he doing that? Synchronizer, just take a look at the synchronizer. Two stages width. So it's just creating a register of the width wide and stages deep, and then it does reclocking for them all. Sam says it's interesting that a system Verilog, a fair amount of system Verilog is supported by Yosis. So you're going to need all of that. And then there's SPI wrapper. And then there's the ALUs. Yeah, it's nicely made design. Nice and modular. So I'm going to need the what else do I have here so far? Rising, falling, reclocking, SPI reg, SPI wrapper, synchronizer, and I'm going to take that as well. And I'm going to take all of the test. Whoops. Don't know what key combination that was. Oh, we've got Chow on the chat. Maybe you can tell me if I'm getting your name pronunciation right. Yes. So yeah, cross domain crossing. You're welcome. Thanks for submitting such a cool design. You can answer any of my questions. So here I'm gonna move this to TTMU, TTUM, then SPI. What did I call it? I've already forgotten. SPI test. What to do? Do I leave your copyright in, or do I just say design by Chow Alonso? Definitely gonna link your design in here. SPI test. Kyle. Okay. Thanks, Kyle. Yeah, so I don't think there's a lot of stuff here I'm not going to need. These are the number of registers. So that I think that's great. That also means that I can just change these numbers. So I can leave them for 8. I can leave number of status registers in there. So now I've got my config regs, my status regs. But I'm kind of hoping that I can get rid of all of this because it's unrelated. It's all to do with the ALU, how it's mapped to the ALU. So I think that's what I get left with. No hiccups yet, Kyle? Right. I wonder if the test would still work. Kyle, maybe you can, that's something you could answer actually. When I was looking at your tests earlier, it looked like it was just testing the SPI stuff and not the ALU stuff. Maybe you can confirm that. Yeah. Okay, what am I missing? Oh, I probably need to edit the test bench. That's it. So whoops. unresolvable bit in binary string Z when it's trying to get a bit from the port from meso bit, SPI meso read, sreg. Maybe it's because I deleted all the registers. Or maybe I needed to like connect them to each other or something. Oh, these are just wires at the moment. Did I delete the actual registers? Or are the registers somewhere else? I guess they're made in SPI wrapper. Or SPI reg. Yeah. Kyle is saying that's correct. So, Kyle, what have I done? Have I deleted too much stuff here? I can see that's still connected there, SPI meso, which is then going into the SPI wrapper. But when I run the test, UO out is always ZZ. Yes, Derek. It's a design by Kyle, and it's for a classic ALU chip. But the reason I was interested in it is because it's got a very nice SPI wrapper, and I'm just trying to make a test version that I can then use for my VGA clock to have access to some internals easily. But it's looking like I've deleted too much stuff. UO out user. Kind of, I feel like that doesn't matter though, the UO out. And you can see there's some stuff. I mean, a bunch of stuff is actually happening that looks okay. That's coming from the design. So maybe it's all right. It's just failing here. So it might be something particular. $472. Okay. It's reading status registers that may well not be attached to anything. Although that does look like it's fairly early in the test, to be honest. Although in Kyle's design, one thing I did notice was there's read-only registers that always output a certain number. So maybe it's because I've deleted that. Because this stuff worked. And now it's reading from address 8. Read-only register. What I might do now, though, is just put in some information here. Probably can grab all of this, actually. Kyle says, got it right. Comment out the read from address 8 to 15 and remove the search from the test. And Sam says, yeah, if you've got no tests, then the test can't fail, can they? That's how I like to live. But the read from address 8 to 15. Right. But where are those? So I guess I'm missing something here. So I've got these status addresses, don't I? I've got these status registers. Oh, the status registers all come from the ALU. Is that what it is? No, they go into the SPI wrapper. But they all, there's the fixed ones. Okay, so the other thing I could do is probably copy that, put that in here, and then for this stuff that I don't have, just assign it to zeros. Looks like it's running for a bit longer this time. Okay, so let's quit all of that. Docs, info.yaml, test, make file, test, readme, test requirements, test.tb, test.py, all of source. Just before I push, I will turn on deploy from GitHub Actions. And we'll see if this actually builds the GDS. We just got up to the top of the hour, so I'll finish soon, but interesting to see if this actually works. We can see what's going on. Oh, look, and the test pass as well. So that was it. Yes. Ciao. Kyle is saying status registers are just wires from internal nodes in the design. They're not real registers in the design. Yeah, that's fantastic. So that's like when I add it to my clock, I can have that so that it can read out like what the clock thinks the time is. I'll add some more comments and documentation in terms of like reusing this excellent bit of IP from Kyle. And I think it's a really nice way of adding, because one of the issues we've got, the reason that Kyle needed to do this was we're limited to 24 IOs plus clock and reset. So if your design is doing more stuff than that, how do you get around it? And I think this is a great way of doing it. Like the GDS failed. Looks like I messed something up in the info.yaml. Yes, I don't know, I just pasted it in without deleting the stuff I didn't need. Yeah, Kyle, I think actually you've done a very good job on the documentation as a whole. Really like how you've done it. I think either you or I could add some information about how you can maybe like a design without the ALU in it, which is kind of what I'm trying to do here. Or like a bit of info from your design to say, if you want to repurpose this, then here's what you need to do. And there's like some basic instructions. But yeah, I think like it, you know, I've managed to look at your design, test your design, and steal your IP for my design all in an hour. So I think it's not bad. Pretty good. GDS has failed again. Oh, I have to add that, do I? I thought I didn't need to if it's there. Just as we're finishing up here, any questions from anybody, related or unrelated? And yeah, just gonna keep on going for a little bit longer, but for people that need to go, thanks for joining as usual. So next week I need to confirm I'm going to Denmark for a tiny tape out workshop, and I'll be visiting a friend in Amsterdam on Monday. So I need to work out what's more important, an open source Silicon stream or hanging out with my friend. What do you think? So could well be that I don't do this on Monday. Either way, please subscribe to the channel, sign up to the mailing list, give this a like. All that stuff is appreciated. Kyle says, yes, you can create a clean repo just with the SPI peripheral. I think that's a good idea. And if you do it, I will give you a coupon for a free tile on Tiny Tapeout 10. So we can have it taped out then as well. Sam says, is there status on using latches instead of full flip-flops to save area? I don't have anything concrete here. I know that latches are proven to be difficult for Yosis. Various people have tried latch memory, and then Yosis optimizes it all out. I think if you look for Yosis issues latch, I think Tommy Thorne might have opened this issue. But I've definitely had problems with them before. So I can't really give you a proper answer on that. I don't think it's supported at the moment. And Malav says they have an undergrad in electronics and communications. I'm not someone who paid attention in college, and I'm pretty much a dumbwit. Do you think it's a lost cause to learn now? Absolutely not. And Stixu says the same thing as well. It's never too late to learn. Learning is a skill in its own right, in my opinion, and learning to learn is important, and then you can apply that to everything. For me, I think an important thing to do is to find a way to make it make sense to you. It's hard to learn stuff that you don't care about or that you're not invested in. So, and Sam says, as a fellow dimwit, you can do it. So I would pick something that you're interested in doing and use that as something that helps you progress through. Okay, this is still failing. Probably going to have to give up in a minute. Undriven UO out. God damn it. We're on to actual errors now, though, so that's good. And this is because I didn't drive. There's all of UO out and not sin UO out equals 0. CJP says it's never too late. Michael Welling gives a pink high five. Hi, Michael. Good to see you here. Anyone else got advice for Malav? How to start learning now? You went to college, you didn't pay attention. Now you want to get back into it. What should you do? Superconductors and apply that to ASIC. Is there a roadmap? English is not my first language, so sorry for not making sense. Well, your English is very good, even if it's not your first language. Don't worry about that. A lot of people, I think, take kind of spelling and grammar, they take it too seriously. And I think if people want to understand, they can understand. And I see, like, as an English person living in Spain, I see this. Like, I see people, some people want to understand my bad Spanish and we can have a conversation and other people aren't willing to, and so we can't. So a lot of the times it's dependent on whether it's not your fault, it's the other person's fault. I don't know anything about superconductors and applying that to ASICs, so I would probably look at superconductors and look at ASICs. And this is what Stixu says. Check out Harris Digital Logic Design Textbook. Sam says, always start on a project you feel is a bit out of reach and try to make that work. I totally agree with that. I think, yeah, you want to choose something that's ambitious and then stick to it. And that project should be something you really care about doing, so that as you run out of energy and lose your passion and what would when you would otherwise fall off, that thing, the reason that you chose that project, that it's got a fundamental interest to you, is what keeps you going. One of my first most challenging FPGA projects, because I found FPGA really challenging to start with, was doing like a virtual graffiti project, which I had done with like infrared cameras and computers and C software. And it always bugged me that it had like 80 milliseconds latency, which always felt too long. So I was like, if I could do this with an FPGA, then I could get that latency right down. And I had to learn how to do frame buffers and DVI drivers and talk to I2C peripherals and all kinds of stuff. And it took probably a year of working in my spare time to learn how to do it. But I kept on going through it because I really wanted to get this project done. I really cared about the project. Oh, GDS is still running. That's a good sign. We've got past the linter. Oh, no, we haven't. We haven't even installed the app yet. Have we? What's going on? No, this is all just the install. Yeah, okay. Yeah, no, I haven't started. Oh, no. Is that working? Oh, yeah, look, the GDS is done. Now it's running the pre-check and the gate level test. Didn't think about that. I wonder if the gate level test is going to work. Rohan says, start with CMOS VLSI designed by West and Harris. Maybe port examples from HSpice to NGSpice. That's interesting. So I've got 35% utilization of one tile is just the SPI stuff. So if I go to my VGA clock, %. So I can add that SPI register to this design, and that will take me up to around 80%. But I can make this design a lot smaller because it's using 120 flops, because I've said I want 8 registers of 8 bits, and I may well not need that. I mean, the time is stored internally by the clock anyway, so I don't need 2 sets of registers for that. Yeah. Timon's saying, worked on a virtual spray paint installation. That's really interesting. Like how I met Stuart, like one of my best mates who is now involved in Tiny Tape Out. FTG spray. I don't think there's. Yeah, you can see my repo. 2016, nearly 10 years ago. I've got it up here though. Look at this cool virtual graffiti spray can. It's really heavy, chunky. I wonder if it's got probably no batteries. Yeah, really heavy. If you do some damage, if you put that in a sock. And Malav is saying, thanks everyone for the encouragement recommendations. Yeah. I mean, a way to get super simple started would be to go to tinytapeout.com, go to guides and workshop, and then just work your way through all of these. And that will take you to the point where you could tape out a simple digital design and kind of give you insight into the ASIC process. I mean, semiconductors is such a huge field, which is why there's so many different types of jobs inside it. But yeah, there's a lot of opportunity, a lot of interesting stuff. Find something that you're particularly interested in one of these aspects and learn more about it. Oh, Sam, you think you could see it? I don't know. Maybe a bit. Let me turn off this light. Oh, yeah, just... Almost certainly wouldn't get detected, though, by my sector. It doesn't look very bright. I used the detector from the Wii remote. Remember that games console, the Wii? And it has like a little... you could point it around and it would know where it was because it had a little infrared camera inside, like reasonably good resolution, I think like 800 by 600. So you could buy those secondhand off eBay for $20, extract the sensor, and I made a little breakout board. Here's my breakout board. No picture. Back in the days before the 3D viewer was a thing. And then, yeah, then it could detect where the can was and do it on a DVI like projector or screen. But it was great. It was so low latency. It felt amazing compared to the computer versions. All right, look, is this where we're at? No, that's the clock. Let's see. Did we manage it? Fail on the GL test. I guess that's not surprising. The pre-check is a bit of a bummer, though. K layout. This is probably this annoying thing. Failed. So front end of line failed with one. I'm guessing this is this annoying thing with two of the wrong standard cells next to each other that is still not resolved in the current PDK. Does anyone in the chat know about this? Come on, I know there's more than two errors because it says error at the end here. Or maybe it's failed. Okay, well, I guess I'm going to leave it here. But keep your eye on the Tiny Tape Out 10 Discord channel because when I get it fixed, you'll see a notification there. We'll just end with one last question. Zuba says, What's the difference between Tiny Tape Out and OpenLane 2? OpenLane is the tool that we use to convert the Verilog to the GDS, which is then what we put together. We take all those little GDS blocks and bond them together into one big chip and have that manufactured by eFabless. And that service is called Tiny Tape Out. So you can pay a bit of money, $150 for the early bird to get your square taped out on a chip and have the chip sent to you on a dev kit. Okay, so thanks everyone for joining. Went on a bit long today, and hopefully, so yeah, probably not next week, but the week after. And have a great rest of your week. Thanks for joining.